Perfect. All right, welcome everyone to this webinar. I'm watching the numbers go up on the participants. So while everyone's joining, we'll start off with introduction. So today we're going to be talking about underground technology for machine control and surveying purposes, and some of the new things and innovative approaches for underground construction and tunnel construction. And today I'm joined by Mathias Knoll from VMT. I'll quickly introduce myself and then Mathias will introduce, and then we'll get started with the presentation. So my name is Riley Smith. I manage the Trimble Monitoring, Mining, and Tunneling Solutions based out of Westminster, Colorado in the US. And I'm really excited today to be joined by Mathias here from VMT. So I'll let him introduce himself.
Yeah, thank you, Riley. Thank you also for the opportunity to present here today. My name is Mathias Knoll, working for VMT. VMT is well known in the tunneling industry for their guidance systems, German company based in the southwest of Germany for over 30 years. And I live in the US, so basically taking care of the business here in North America, which includes the United States and Canada for almost 15 years now. Yeah, and I'm based here in Seattle. And you will see also Seattle in the Super Bowl final. I don't know, Riley, how your team did last weekend, but I think you slightly missed the final. But anyway,
sore topic, I guess.
Yeah, sorry about that, but I had to put this out.
Awesome. Well, thank you, and really happy to have yourself and VMT represented in this collaboration. So I'm really looking forward to the webinar today. So for everyone who's joined, so we'll kick it off. We'll kind of cover the agenda here for you. So Mathias will kick us off giving a introduction to VMT for those who aren't familiar and what they do, but then also talk about some of the new innovative approaches that they're taking when it comes to tunnel guidance and different tunnel systems. And then the second half of the presentation will look more on the surveying side, and I'll cover some of the things that Trimble is doing. And then we'll end it off with some kind of future-looking aspects and maybe some hints at directions we're working, and also what Trimble and VMT have been doing together. And so if you are working on tunneling projects using the combined technologies, how you can benefit from those things. All right. So let's kick it off maybe with a poll for everyone. So I'm going to start up a poll, and I would appreciate all of you to fill it out. It gives us a little bit of understanding of where you are in the world and your backgrounds and so forth in the industry. And also kind of maybe we can also tailor some of our content as well to based on your answers. So if you just take a brief minute to fill out this poll, and then we'll look at the results. And then maybe while we're doing that, Mathias, if you want to start intro to VMT.
Okay, yeah, please enter the poll. It would be great getting some feedback, about the audience. Since we can't see you and we don't really have time to chat with you in person, would be great to get a little bit more connected, because I'm pretty sure you're joining from different parts of the world. And the goal is here to bring you a little bit closer to the underground. What happens in the underground doesn't always need to stay in the underground. A lot of us don't even know what's happening below our feet, but there's a lot of projects going on for different reasons, public transportation, improving utilities in urban areas, and we don't even know what's happening. Some people using a train later on a subway and don't even know how it was built, what was involved in this. And we as surveyors, we are on these projects, we are involved from the beginning to the end, basically. One of my old teachers told me the surveyor is the first and the last on the job. So we are closing out the job site, and there's a lot of important stuff going on where we are involved as surveyors, and there's nice tools that we utilize in the underground construction. A little bit for VMT, giving you a little bit insight what we do as VMT, not just well known for tunnel boring machines and the guidance systems. We also have a different kind of solutions around tunneling. But to give you a little bit insight when it comes to tunneling, first of all, there's different methods, different tools, how you excavate a tunnel, how you choose this excavation tool. Let's call it this way: a tunnel boring machine, an excavator, and rotator. Really depends on the ground conditions, depends on safety aspects, and for sure it also depends on budget. Not everybody knows maybe how a tunnel boring machine works. So here's a nice short animation from the manufacturer of the tunnel boring machines, Herrenknecht, which is actually the mother company of VMT. And the majority of these tunnel boring machines have also the VMT system on board. Just to get a little bit of insight here, this is a 12-meter machine, 40-foot diameter, excavating through the ground. It's like a little bit like a little factory. What happens here, the cutter head in the very front of the machine is turning, excavates the material, the material gets extracted from the underground while the machine is pushing forward. And then behind the machine, you're building these called rings with precast tunnel segments. And for sure, think about a subway project. You need to put a track into the tunnel. You need to have we have very tight tolerances. That also means it puts a lot of pressure on the surveyor, not just when the machine comes out of the ground for breakthrough, where everybody's waiting, and the surveyor's heartbeat is the highest. No, also while you're tunneling, you always want to ensure that the machine remains properly on line and grade, so that you can later put in your tracks properly. So challenging ground in the tunnel. As you can see here, some pictures of colleagues working in different kind of tunnels. So not all tunnels all look like this one here. Very nice tunnel, easy accessible, a lot of space. There's also tunnels with really small diameters. I mean, we have sewage tunnels, 4 foot, 1.2 meters ID, and then up to 500 meters, 1,500 feet long, or sometimes even longer. So contractors also like to push the limits. The machines can do more and more, but what can you do as a company also to not just keep the contractor happy, also keep your own people happy, so that they in the future don't need to crawl all the time into these tunnels anymore, because it's also not getting easier finding the people to do this work. A little bit background about VMT. As I said, over 30 years now, and I am working in the US, taking care of the business here. We have a group that mainly is focused on tunneling projects, but at the same time we have a metrology team that also is involved in car manufacturers, airplane manufacturers. I call them the sub-millimeter team because they work with laser trackers and have to work with sub-millimeter accuracy here. This is not necessarily needed in tunneling when it comes to the TBMs, but there is precast segments being used which in tunneling have tight tolerances, where our team from the metrology is also involved in. Different methods, as I mentioned, TBM tunneling. Micro tunneling doesn't always mean just small diameter. It's just the method how you tunnel. You can have a 4-meter micro tunnel machine, for example. That's not a micro tunnel in terms of the size, but in terms of the excavation method. And then there's conventional tunnel. Conventional tunnel can be one where you use a shovel. Still happening that people excavate with a shovel some short tunnels, because it's the most economic one, but there's other methods, drill and blast, or excavator, or rotator. Just a little bit some milestones. I don't go in detail, but we have a pretty good track record with more than 3,000 projects around the world. When it comes to guidance system, if you're always wondering how these systems are working, we are the Google Maps basically of these tunnel boring machines. There's no GPS. So how these systems are working, I will show you a little bit closer in the next slides. But it's not just about the TBM itself, it's also about what's happening behind the TBM. Is there any deformation of the tunnel? So we have also solutions for this. And then for other parameters of the machine that need to be monitored. So this is a nice animation that shows you how guidance system is working on the tunnel boring machine. A total station-based system. Total station is here mounted on a bracket in a fixed position. You have a backside target, and then you have it's called a laser target sitting in the machine. You know the location of this target, and based on these measurements, you can determine the position of the machine. And not all tunnels are straight. We have curves, we have slopes. So we all need this to take in consideration when it comes to using the guidance systems. So some closer look here of a guidance system, call it the classic again, where here the Trimble total station is sitting on a bracket mounted on the tunnel wall, on the precast segment. Here is the laser target unit that's mounted inside the machine. Here you can see an operator using the VMT system. So the operator has a lot of screens. These are not different TV channels like in the pubs where you see different kind of sports shows at the same time. The operator needs to monitor parameters on the machine, and at the same time also obviously to have a look on where the TPM is going relatively to the designed alignment. And there's certainly developments also that you want to automate the TPM operation in terms of steering, where we also contribute as VMT to the automation. And remember, we had the tunnel bracket on the tunnel wall. We also found a different solution for guiding a TPM with a more, here call it the innovative solution, the moving station, moving the total station away from this fixed bracket, put it on the actual machine, and then with resection, we are getting the coordinate of the total station. So we have several backside targets here on the tunnel wall, and then measure to the actual target in the machine. You might wonder, okay, how does the total station stays leveled? For this, we have self-leveler. So this is the self-leveler we used in the past. We have now developed our own self-leveler. This is a smarter self-leveler because it also has an internal inclinometer. Gives you also direct feedback about, what kind of movements you have, so you can analyze better and can utilize this information. Also, if you have vibrations on these machines, there's some better detection of potential error sources. And the good thing is also that the surveyor or the engineer here in this case can use an app, a tablet, and can control the total station through the VMT system. So there's no need, like in the past, you always had to kind of run back into this operator's cab and then from there control it, just to simplify the workflow, make the work easier, or troubleshooting. Yeah, so this is what it looks like in the operator's cab again. And we're also trying to take these parameters from the machine now. The machine learning is not because the TPM is necessarily learning, right? So machine learning is out there, the phrase or the word for a lot of topics, but we're trying to get more parameters for the machine that we can incorporate into the guidance system to also utilize calculations of the TPM position without, for example, total station. For example, there's no line of sight between the total station and the target that we can continuously give a position for the operator. We don't want to fully exclude the total station, but we want to ensure we always have a permanent position for the operator, especially in critical areas along the alignment. Imagine you're going from a tangent into a curve. You want to make sure the operator always has the position available at all times. Yeah, and there's a closer look to the app again, where you can have your mobile device, cell phone or tablet, and then can just control the total station that's sitting here, in this case on the bracket, and you can do your resections, or you do your orientations, or set new prisms, all through your mobile device. So this was a little bit about TPM tunnel. Gave you a little bit of insight about what's happening with the tunnel boring machines, but there's also conventional tunnels where you excavate with a road header. It's this machine or with an excavator. So here, while on the TPM, you never see the face, which is the very front of your excavation. In the conventional tunneling, you always have direct access to the face, which also means is a little more safety even plays a more important role here because people are even more exposed to the ground, to the geology. And here in this nice animation, you can see how a total station is being used in this case on the road header. So you have two prisms mounted on this road header machine. We know exactly where these prisms are located relatively to the center of this road header. So you have a local coordinate system, and then the boom in the front is moving left and right and up and down. And we are calculating this position continuously relatively to the profile they need to cut. And imagine cutting the profile here is critical because you have tight tolerances, and the more you cut from your profile, the more shotcrete you need to use. The more shotcrete you need to use, the more money you need to spend. So that's why you want to be within the tolerances and want to be as precise as possible. And then the total station here can be used at the same time also for this rock bolter, which reinforces the ground. And the rock bolts also need to be documented in terms of their position, how they were drilled, where they were drilled. And then the data don't only stay in the tunnel, they're also getting transferred to the surface so that it can be accessed by different stakeholders on the tunnel project. And for analysis, also for configuration on the surface. So the good thing is now, since the surface is very well connected on most jobs with the underground, you can also do your configuration on the surface and do your updates directly and transfer them onto the machine. So there's no need that people need to take a pen drive and then walk down, need to wait for a man basket to be lowered into a shaft and then walk another 2 kilometers to a machine to update the data. No, this can be done directly in real time from the surface, which is absolutely great. It makes also the surveyor's life easier because the surveyors also have a lot of other topics to do, and you don't necessarily want to spend several hours just by walking to a machine to transfer some data. And as I mentioned before, we're trying to share the total station for different applications in this conventional tunnel. It really depends on what is being used here. But since you have one combined system from VMT, the systems can be used on different machines, and then which eventually also simplifies the process that these machines can directly connect to the total station, because they're normally not working all simultaneously, right? It's a cycle how they work. And you start with your excavation, and you maybe have your rock boulder. So whatever machine is close to the face will use this total station that's mounted on the tunnel wall. And yeah, in this case here with the shotcrete rig, you use the total station to georeference the scans so that you have a full georeference scan which can be compared to the design. That's quite important for the shotcrete application, because you need to see exactly, okay, what was my excavated ground? I've overcut, undercut, where do I need to apply more shotcrete? How much more do I need to be within my tolerances? It's not just about the thickness. Some jobs also use the shotcrete as their final lining, where it becomes really important that you stay within the tolerances. And we also did some use cases here with the HoloLens, the Trimble HoloLens, where we try to visualize the results of these scans onto the HoloLens. Unfortunately, Microsoft will discontinue this product, which will also result in a change for us. So we'll see what comes after. But it is something, an interesting case for an operator, that the operator can wear the helmet and can see in real time by turning its head, her or their head, and see where to apply what type of or how much shotcrete based on the scan results. Shotcrete is one option for lining in tunnels. Another option is using formwork. Some jobs are struggling, like these 3 people here, to place this formwork in the tunnel relatively to the design. And this can be quite an iteration, a long process, sometimes of going back and forth between measuring, getting the results, then deciding how much you need to move this formwork left, right, up, down. And for this application, we also have an automated solution now, which simplifies the setup of these different kind of formworks in tunneling. So this is also like a guidance system for a tunnel boring machine. There's, in this case, no total station involved, but you're setting up markers that are getting surveyed by a surveyor on site, and then the cameras here are detecting the marker. We know exactly where these cameras are located inside this formwork, and based on the results, the operator gets the position of this machine, of this formwork relatively to the design, and can then decide how to move the hydraulic jacks to bring the formwork, the center line, spring line of the formwork exactly onto the alignment in the right location before you start pouring the concrete. And it's not just about placing the formwork, it's also monitoring the position of the formwork while you're pouring the concrete, because there can be potentially movements. Now think about a surveyor being there, continuously monitoring, coming back down there and shooting while they're pouring. This can be quite an endeavor in some cases. In this case here, you have a continuous recording of the position, which will be also directly transferred into reports, where a contractor can go to the owner, say, look here, we had no movements, minor movements, everything went fine during our concrete pouring process. back to the excavation. Yeah, excavation with an excavator. You know all the machine control, great machine control from Trimble for the surface. In the underground, it's a little bit different because there's no GPS, so there's a little bit more. It's a different environment here. Again, using a total station mounted on a tunnel wall. We have 2 prisms, and then there's an additional device to get the slewing for the excavator, so that you can have also this position here as accurate as possible. And we're also talking about accuracy of less than 10 centimeters. So that's also quite crucial that you have here a very accurate position when it comes to cutting a profile with an excavator in tunneling. And the operator also sees here on the screen directly in real time where the excavation tool is relatively to the profile. That's quite important, because normally there's, as you can see in the top right, is a surveyor close to the face, sitting there, pointing a laser in some locations, measuring, giving feedback to the operator. And A, it's not the safest environment all the time, and B, it's maybe also not always the most efficient way to do it. And if you have an automated system for an operator, which doesn't always require the surveyor to be there, then this is a great option. And it's not about taking away the work from the surveyors. We're facing times of workforce limitations, and on these tunnel jobs, there's so much more work to do for surveyors. So that's why it becomes also quite crucial to have some more automation in terms of guidance on these kind of machines. For a smaller diameter tunnel, it's one of the last applications I want to mention is the multiple total stations. The idea is that you have an automatic traverse measurement with utilizing total stations, a little bit an older animation. But what these total stations do, they measure each other. There's prisms mounted on top of the total station. They measure to each other and then do an automatic traverse measurement, which is needed to not only calculate the position of the machine continuously, it's also used for surveying purposes in terms of updating a machine position. The last use case, little insight using AI. The AI is here not necessarily used for measuring, it's more for detecting the quality of the segments here. These are the precast segments that are being used to build a tunnel. You use several segments, put them together, for example, 6, 7 segments, and then they create this one ring that's being used to basically protect yourself from the ground and also push the machine forward. And here the AI is automatically detecting the segments, making sure the quality of the segments that were delivered on this tunnel boring machine fulfill the requirements of the QA, QC, and then it's being documented. Just another case to explain you, where we use AI already, and for sure there's more topics to come. Also in terms of analyzing data automatically that are coming from a tunnel boring machine, from a guidance system, so that taking away some additional work where people are sitting and digging through data, let us put some more automation into this, because our time is valuable for other topics, and we should not go through a bunch of data if there's some sort of solution out there that can do it automatically for you and then maybe tells you there was a problem or there was no problem. Yeah, this was generated with AI. As you can see here, there's a problem in some areas with the graphics. This is how AI still is nowadays. You cannot fully rely on it. You still need to use your brain, but it was, in this case, the easiest and fastest way. Give a little bit of insight. For sure, the goal is at the end, bringing everything together, streamline the workflow on the tunneling jobs, different solutions. In the past, there were always like little islands, not communicating with each other. Now it's time bringing the data more together so that you can also, as a contractor, as a surveying company, as an owner, make better decisions, faster decisions by using the right data. And I would say I hand over to Riley.
Awesome. Even though it's not the first time I've seen this presentation, it makes me excited every time. Some great things that VMT is doing.
And we make boring exciting again.
I'm going to try, and we'll see if I can share the poll results here. Just take a quick break from the presentation. Hopefully people can see that. If not, I'll just kind of verbalize it. So it was great to see. So thanks for everyone who filled it out. We have a pretty awesome representation from North America and Europe. Not surprising because of the time zones. So thank you for joining, and those where it's a little bit later in Asia and Africa, also thank you for joining. It's interesting to see the split. We have quite an even split of people who have worked on tunnels, a little bit of work on tunnels versus never worked on it. So pretty even split there. We do have somebody who doesn't like underground construction. So hopefully you're going to like it after this presentation. And then there was some really interesting topics that came in on what you're interested in learning. I think you probably already hit on some of them quite a bit, Matthias, with TBM guidance, monitoring, control networks, and a variety of other things. And so I think with that, we'll pivot here. We've talked, Matthias did a great job talking about definitely on the machine side of the world and some other great things. I'm going to now here share my screen and talk more on the tripod kind of side of the world in tunnel surveying. And these two worlds are not disconnected, in my opinion, and that's why Matthias and I are presenting today. There's a lot of crossover and similarities in the technology between the guidance side and the boots on the ground surveying perspective. And the way I want to kind of go over this is thinking about the workflow, and a lot of the workflows I've heard of from many of you, maybe on the webinar, and many tunnel surveyors out there, and some of the challenges that you're facing, and some of the changes also in the industry. So really, when I look at a tunnel project, this is where it starts. It's usually with some kind of design, PDF, blueprint. I've even walked into some offices and seen a lot of paper plans still strewn about desks and highlighted and marked up and everywhere. And that is the way we've operated for many years. But what I'm starting to see change in the industry is these more complex, more detailed models. For example, I'm showing here in the video is one produced from one of the Trimble softwares, Tekla, for doing civil and structural design, creating these very detailed, not just from a 3D geometry standpoint, but also the information in that. And so surveyors have to take that and turn it into a usable survey-ready deliverable, right? Which is different from using points and lines and coordinates. And so a lot of what Trimble's been developing in the past is how to take that information and make it ready to use for survey needs in the field, like you see on the right-hand side with Trimble Access, where we've implemented 3D models so you can stake out directly to that. But okay, that's one thing. We have the ability to use that data, but we're still a lot of the time transferring files manually to site. We're using USB keys, and a big shout out to the folks at Frontier Precision for this great video on how to do that. But the industry is changing. We have a lot of crews on site. We're getting design revisions really fast, and we've got to turn around and have the latest information. So we're making sure we're using that in the field to stake out, to set out, to guide, whatever the workflow is. And so one of the workflows that we built is this connectivity between the field and the office through Trimble Connect as a common data environment to take that latest design information, get it to the field, or even get it from the office, and vice versa. So in this case, I'm showing a design, but it could also be field data from the data collector into the software for processing, and making sure we have the latest information so we can turn around deliverables in a more timely fashion. And then there's a lot more of this traditional, what I would call conventional approach to measurement with total stations, and that's not going to change. It's still high precision instrument used in your control networks and monitoring and a variety of things, as well as guidance, as Matthias was showing. But one of the changes I've seen is adoption of reality capture information to do the conformance checks, to do the validation, whether it's shotcrete, TBM rings, or a variety of other things. Okay, well, reality capture isn't new technology. I'm sure many of you are out there familiar with it. But what has really changed is the ability to use that while you're in the field and get some insights. For example, showing here, getting real-time shotcrete checks while you're there, standing not at the face, but close to the face, doing a scan and checking for things like thickness and a variety of other parameters. And I think you'll continue to see this world evolve as devices, tablets, and things get more edge processing capabilities, get stronger and smarter, and be able to do more while you're there, make a decision. So you don't have to go to the office, process some data, clean it up, and turn around a report, and you reduce that timeline. But oftentimes we do have to create reports, or we have to put a bunch of point cloud data together and produce a model. And so we're faced with all of this data, but there's a lot of noise in that data. So you got millions, if not billions, of point cloud points, and you've got girders, and you've got ductwork, and you've got cabling, and people and machines. That takes a lot of time to clean up that data. And I don't know about you, but typically that's one of the things I don't want to do is sit there and manually segment out all the point cloud data from that scan because it'll take a lot of time. And so we also invested a lot into automation of cleaning that data. And so what I'm showing here is a deep learning model that we've developed to automatically detect different features within the point cloud to reduce the amount of manual segmentation that somebody has to do. And so you can get faster to whether it's scan to BIM or scan to report or heat map or any other deliverable. And so here's an example of that where we've taken the scan, automatically extracted the rock surface, the ground or floor at the shotcrete layer, which you can see here close to or further away from the face, and as well even extracted the rock bolts as well in that scan. So quite a bit of detail. And while I think there's still a lot more we can do to continue speeding up this workflow and continue removing other manual steps, this is a great first start of reducing the amount of data cleanup that you have to do in the back office. And as Mathias showed, there's also a lot more move to prefabrication, not just from the TBM side of the world, but other components that may be in the tunnel after it's been built, and you need to validate those things. And so there's a lot of capability to now leverage the 3D model, that rich model, and use the scanning capability to validate that. Now, maybe you might need higher precision in certain cases and maybe laser trackers or things, but I think this allows you to get more out of the tools that you have at your disposal today. Okay, and then how do we get that data, those reports, that information to clients, to stakeholders on the project, right? So we've got some great data, we've processed it, we've turned around reports and so forth, but typically that's not where it ends. It goes somewhere, it goes to someone, even if it's just for archiving. And so this is where we've introduced more of what I like to think of as the town square for geospatial data with Trimble Connect. So a place to manage, store both your geospatial data, but also design and the latest design information that allows dissemination to stakeholders, but also to the survey team for what they can use. And there's also additional collaboration and visualization things like tools, alignment-based visualization, measurements, annotation, and so forth. But it allows that. That allows that collaboration between stakeholders, and they're not necessarily just using a PDF report as that only means of doing that. So I hope that kind of gives you that broad overview of the workflow. But one of the other things I've heard often is the workforce challenges, right? New tools, new workflows, new technology that comes out, and how to keep the team up to date. And one of the things that we've tried to do with from a Trimble perspective is using the Trimble Learn platform to introduce courses and material that you can use with your crews, with your office staff, to get them up to date and know that they have a competency in the workflows that they need to be doing. And I know this can be a challenge when you have a big project that starts up and you're mobilizing a workforce, and getting them up to date and training is a really big challenge. So this platform, I would encourage you to take a look at learn.trimble.com and see a lot of the content that's available for your teams. But there's also different interactive tools that can help experience the site without actually being on site, which can be quite interesting if you have team members who are new to tunneling. As we know, it can be a challenging environment if you've never been in the underground space. And so kind of teaching some of the principles in an interactive way so that they're more prepared when they get out there. They have to do control surveys or they need to get to the face and do a scan. They've got some more ideas of what they need to do on the technology when they're in the field. Perfect. So hopefully gives you some ideas of some different ways you can explore updating your workflows and looking at ways to streamline some of that. So Matthias already talked a bit about the looking into the future and some of the things that we see changing and from a technology standpoint, how we can update those. I do also want to cover why we're doing this webinar today. Well, one is to educate everyone and provide some content and learning for all of you, but also Trimble and VMT are working together to hopefully bring more value to our customers and our users in the industry who are using our combined technology on projects. So some of the ways that we're doing that is we've obviously seen in some of the pictures, Trimble total stations are supported with the VMT TBM guidance system. So if you are using Trimble total stations to do your surveying, you can also use the same instruments with those guidance systems. And one of the other components that I've seen often is the surveyors, as Mathias said, which I really appreciated, was often first on site. They're often the first one handling the data, the design information, and preparing that for use. And you want to use that information also in your guidance system and further down the line. And so we introduced an ability to take the design from Trimble Business Center that you've prepped and you've got ready into the guidance to VMT guidance software. So you don't necessarily have to build it again from scratch, and hopefully reduces that office time. But also if you have revisions and so forth, you don't have to go back and redo all of your designs and so forth, and it's just a transfer. So some of what I hope are the start to many other things that we could do in the future. What I would encourage all of you is to reach out to Matthias, myself. You can find us on LinkedIn, but also if you have your VMT or your Trimble rep locally, to talk to them and understand how we can potentially contribute to your projects. So I think with that, we're gonna now save some time here for questions, comments. I'm just going to pull open the questions here. Please use there is a QA spot. Please use that, and Matthias and I will go through that.
Riley, I like your simulation, how you get people on board for the tunnels. And the only thing I miss is the water, the noise, and the dirt in this animation. Otherwise, people who are playing around feel like, oh, that's a nice environment. We should also make people aware of what they have to deal with when it comes to the underground.
New VR experience.
Yeah, I'm pretty sure there's something you can do in the next iteration. And we have also one person who's afraid of tunnels. I just looked in the polls.
Yeah.
Maybe after this presentation, the person is less afraid of tunnels, or we have now more people who are afraid of tunnels. We shared our information.
Especially with your VR simulator with all the dust and noise.
Yeah.
Make it more approachable, I guess. All right, I haven't seen any questions yet, but if there are, please feel free to type them in. Keeping an eye out here. There we go. All right, so Aaron asked about speak more to the collaboration between VMT and Trimble, specifically where the respective hardwares and software come together. So maybe I'll do a quick answer and then I'll let Matthias also on his side. So the initial collaboration, as I mentioned, was to allow Trimble total stations to work with the VMT guidance system. As Matthias showed, they have great guidance systems there, driven by total station data, and also with the ability to take design information from Trimble software. So if you've prepped your alignment and all your profiles into the Tunis, the VMT guidance software. I think there's a lot of other things that we can do in the future, and that's where we'd like to hear from you. There is some considerations on the type of VMT hardware that you have to use with the Trimble total station, and maybe I'll let Matthias comment there.
Yeah, that's correct. So let's say let's say every hardware, especially when it's older hardware, is necessarily compatible. So that sometimes we need to look from case to case. So that's why it's good when you have a project, reach out to your contacts in your region at VMT or reach out to me. Happy to look in this. But overall, it's really important to simplify the workflow between Trimble equipment, VMT equipment, especially when it comes to configuration of profiles, alignment. Because the worst thing you can do is you have one software, you create a profile and alignment, and then you have to do it again the VMT software. Now you have a change in one software, you need to do it in the other one. And so in the VMT, it makes it now easier with the Trimble. We can import the data. So we found a way how we can easily get the data transferred and then import them into the VMT. So you always have more or less the consistent data. For sure, in the future, I hope there's also a more automated process so that we always have the right data available. We have seen it in the past that people, have different kind of documents about alignments, and then all of a sudden, you find out that the machine is offline because somebody has never updated the alignment on the tunnel boring machine, right? So these things need to be avoided so that you have consistent data across your different platforms. It's not an easy way to do. It takes time, like it is in tunneling. It's just most of the time a steady progress. Sometimes you have to stop for a little bit, but at the end we have a goal. We have to work on this, and it's a matter of time that things will get easier. But also you as a contractor working on a daily basis with stuff, we are happy to get also your feedback, your ideas, your wishes, because at the end we live also from you, because we make the products for you. So your feedback is really valuable to us. So that's why ideas, questions, we have more now in the Q&A, I would say.
Yeah, Casey looks like it's an agreement with that statement around managing designs through multiple systems, multiple guidance, CAD, survey software, all of that, and definitely, and I think you answered it really well there, Matthias. We're making progress, but there's still work to do there to try and make some consistency and make maybe some automation as well, so that between machine guided systems, CAD, survey, all of that, we're running on the same information.
Mm-hmm. We got a question here from chat. Can you speak more about how the guidance system work for SEM? So sequential excavation method, which is, let's say, the conventional tunnel, in particular the road headers, rock boulders, hammers. And what are the differences from a TBM guidance system and its current limitations? So what do they have in common is, first of all, they're both either the TBM guidance or the conventional side, we're using the total station. That's one of the essential elements. On the TBMs, we have more a laser target unit, which we mount on the machine. We know exactly where this is located inside the machine to eventually get the center of the machine calculated to the alignment. So this is crucial here, while the profile that we cut with a tunnel boring machine is always more or less the same, because it's defined by the cutter head. That's the big rotating head in front of the machine. This defines the profile, while in the conventional tunnel, your profile is defined by how you move on a road header, the boom with the excavation tool relatively to the actual design profile. So here, the profile is really crucial. It's not about necessarily only about line and grade being on alignment. It's really where sits your profile to the design, and what you are cutting fits, matches the tolerances. So this about the road header excavation. Hammer, maybe you're talking about using a hammer on an excavator. Not 100% sure if this is correct or not. At the moment, we are more using the excavators with other excavation tools. Even you can have a road header, a drill head mounted on an excavator, or a bucket for excavation. Hammer is, let's say, in terms of accuracy, not the best option for a guidance system in this regard at the moment. So that's more limited cases. If you use a hammer on an excavator, then it's also maybe not the right ground for an excavator with the tool. And rock boulders, utilizing the total station, similar. Yeah, thank you for putting the animation on. Yeah, here's as you can see here, the rock boulder, where we also position the rock boulder. We know exactly where the rock boulder is positioned with the drill tools here that are setting the bolts relatively to the alignment, so that at the end you have a pre-design of your bolt pattern, which can change based on geology, that you need to put more or less bolts into the ground, and this needs to be documented. They need to be drilled into the right locations so that you're within your specifications for where to place these rock bolts, and then also have some sort of documentation where basically an as-built position for the rock bolt, and this also comes out of the guidance system. So I hope this gave you a little bit more insight about your question.
I think that was a great answer. So another one on the auto level, what is the model name and data logger capability for that smart auto level that you
Okay,
showed? I'll see if I
so
can
the name of
find
it
the slide.
is yeah, thanks for going through this. It's called the TPS level. And that's a VMT development. Before we used from another manufacturer the device, but we also wanted to have more control on our side. And in terms of what are the data logger capabilities, right now we have roll and pitch, so 2-axis inclinometer implemented into this, which also with an additional device will give us some insight about vibrations. So it gives us an idea of what is really happening on the self leveler. While before the self leveler was just, don't get me wrong, but it was just not a smart component. It was doing its thing. It had an LED on it. It told you it was leveled, but you had never really an indication if you had a movement on the location where your self leveler is located. And now when you have an inclinometer now, you can have a data logged and have a timeline, and you can see how the data were changing, which maybe gives you some indication on a monitoring project, for example, if you want to utilize it there, if you had movements on your post related to weather, for example, or anything like this, or if the post got hit. Because if it always stays leveled and you just look from far away and you don't have any more insight, you don't know what happened there, right? So this is for us with the data logging, gives us more information.
I think I'll take the next question, but I'd be curious to hear your thoughts too. So question is from Germain, I think, if I'm pronouncing that correctly, so apologize if not, around how drones could play a part in tunneling in the future. And I think the short answer is we're starting to see some interest, at least from the world I live in the geospatial surveying world. I think there's also an element of adoption, safety, and regulation, is understanding what are the ways we can use those in a safe way as a part of the tunneling process. But drones are getting much better at detection and autonomy in their systems and their payloads. So I think there's some great ways we can leverage that. I see it a lot from a underground mining perspective, where they can play a role in going into areas that are more unsafe, where we can't send humans into. And so potentially that could be an area in the tunneling infrastructure world in the future, but also just the general data capture. It helps keep people away from the face, which is always a good thing if we can do it.
Yeah, and also the payload on the drones, right? They get more accurate. They give you more dense data. They can give you more information. So there's definitely a good case to utilize drones more in the future. Not just for safety purposes, which is definitely one of the main reasons, but also making data faster accessible, and then maybe having these drones automatically connected to networks down there so that the drones automatically transfer the data live. So you can deploy the drones if you need some information quickly and then get the data transferred into your surface system.
All right. Chad wants to know more about the SEM guidance systems. Around two parts here. I'll try to combine these. So specific compatibility with Trimble total stations and the SCM, so rock bolters, road header machines, and then how the positioning of the road header works at the cutting edge. So the implement of the road header and how the total station is used to calculate that.
Maybe for the second part, for how it's calculating. So the total station is first of all only used to position the road header itself. Let's say assume the main body, the main body of the road header, and then you still have the boom, which is mounted onto the main body, and then it's moving horizontally, vertically, and in some cases they also have called a telescope where they can also extend it longitudinal along the boom. And to get the actual boom position, these information is coming from sensors on the boom. So we get the total station measurement to these prisms. Thank you for the video again, for the animation. This is the only thing where the total station is involved, so that we get this main position of the road header. And then from here, we are using sensors in the boom to get the horizontal vertical movement and also the telescopic movement, so that we can continuously in real time display the position of the excavation tool relatively to the design profile. And also you have wear on these picks, it's called, on a road header, so that sometimes it's even important to keep in mind when you have, let's say, projects with really tight tolerances, you have to take in consideration the wear on these picks too, so that you sometimes even have to update the, let's say, the design of the excavation tool. So that's also quite important for the job, where they changed the actual design of the excavation tool, but didn't change the setting in the software. And then later on, you know, they were cutting profile, everything looked nice in the VMT. They did the as-built survey and then had an overcut, because they found out that they eventually used a bigger excavation tool on the road header, which the system didn't know. So this is where a human factor comes into play sometimes, and people need to keep in mind that there's still some interaction between the people who configure it and the actual system.
Good.
And
all right.
How compatible it is. So the system, Trimble Total Station, we have done in the SEM, we have done tests already. Right now we have it mainly used on the TBM tunnels. We are looking more into SEM cases at the moment, but the main focus first of all was, because the majority of the projects is usually more TBM. So now that's why you have to put a focus on this first and see, okay, where are the most projects? SEM, we got the lucky situation on North America, there's projects again, and in Canada. Australia has been a really big market for conventional tunnel with road headers, for example. But road headers, the use of road headers, for example, is also limited, because you need the right ground conditions for it. So if you have really soft ground, you cannot excavate with a road header, then you use a tunnel boring machine or maybe an excavator.
Perfect. All right. And then Casey asked, how long has the Trimble VMT integration team been working together? I don't know how long, but I think this webinar is kind of a way for us to inform and educate all of you, and hopefully more into the future, on these different integrations, and hopefully more to come, right? Matthias said, what we do is really based on what all of you tell us is needed in the industry and what would help your projects. So I'm hoping to hear from all of you on other things that we could be doing that would really drive productivity or safety or whatever metric it might be on your projects. All right. More questions around the positioning system. Not surprised. It's a cool system. So the overall 3D accuracy of and I think this is from Chad, so I'm guessing it's around the road header. The overall 3D accuracy is 10 centimeters. Is that, or is there a specific?
It's more accurate than this. I mean, first of all, the accuracy of the system, you have your internal accuracy of a system, and then you have an external or overall accuracy. The overall or external accuracy, first of all, relies on the surveying network, or the job that the surveyor does to bring the coordinates into the tunnel. That's one thing to keep in mind, because you can have the best guidance system that always shows you that your tunnel boring machine is always online and grade, or with really deviations that are close to zero. But overall, in the absolute world, you are offline because the surveyor did a mistake, and it's a really specific environment. But when it comes to the TBM systems, you can usually assume that you have an accuracy that is in less than 10 millimeters, 5 millimeters accuracy for the TBM machines, assuming the external accuracy is okay. And for the road headers, we are more in the range of 1-2 centimeters, an inch roughly. It also relies on not just it's not the total station only, right? But you have also these internal sensors on the road headers, and they all contribute with their accuracy to the all accuracy to the profile that you can cut. So to give you a rough idea, as I said, 10, 20 millimeters, sometimes 30 millimeters, really depends also on the setup. So when we come and prepare these road headers, preferably in the shop already, then we also do an accuracy check already in the shop. what we do is we let basically the system calculate the position of the excavation tool, and then we shoot the excavation tool independently, so that we can say, okay, the VMT guidance system is showing this accuracy, and with the independent measurement to one of the picks on the excavation tool, we're getting this result, and then gives you an idea about the overall accuracy of the system.
Maybe we're getting too close to end of time, so we'll take maybe one more question here, and then we'll end the webinar. So next on the list is from Abdul on, is the total station permanently positioned? And I think we're referring to in the case of a guidance system, that's my guess here, to that question. So maybe I'll put up this graphic again. I guess this is a good representation here.
For the correct, for the conventional tunnel, I mean, you have to move it forward at some point, because as the excavation is going on of the tunnel, there will be line of sight limitations. There might be dust. On the conventional tunnel, they're trying to dedust as best as possible. But you might have to move the total station, bring it closer, because you have line of sight limitations. I would say usually not going more than 100 meters, and then you move it onto a new bracket. Sometimes you even have to be closer. It depends case to case, from job site to job site. On the TBM tunnels, it really depends on how often you have to move the total station, first of all, based on the alignment, straight, curves. So if you have really tight curves, you have to move this total station more often. So this is always the case with this. We call it the classic mode, where the total station is mounted on a bracket on the tunnel wall. But with the moving station system, the innovative system, the total station is always traveling with the actual tunnel boring machine. In this case, it always sits in the same location. So in this case, it always sits on the self-leveling tri-rack, and you have it always in the same location. The thing is, there people don't need to take it off, need to carry it from one location to another one, and a lot of cases, you know, especially night shifts, they're breaking the total stations or forgetting to turn the knob on a dry rack, and then somebody hits the total station and it falls down. Everything is possible in tunneling, I can tell you.
I think that with that, everything is possible, like Mathias said. So that's a good thing to end the webinar on. So I just want to say a big thank you to Mathias for joining me for this webinar. This was great information, and thanks to all of you who joined and asked a lot of questions too, which is always fantastic. Shows some interest in the topic. I think I can speak for both of us to say, if you are interested or you want to just provide feedback, you can reach out to either of us. Probably the best is LinkedIn, easy to find, and we'd be happy to chat with you.
Yeah. Also, thank you so much for the last 60 minutes. I know there's one question that has not been answered yet. I'm happy to write the answer for the rock balls. But otherwise, yeah, we're looking forward to getting more feedback, because at the end, what we do it for you, we do it for the contractors, and we want to develop products that are right for the market and are accepted. So that's why your feedback is really valuable to us. Thank you so much.
Thank you, Mathias. All right. Take care, everyone, and thanks for joining.
Thank you. Bye.